Okay, so this is lesson 3.5 B, the second half of this. So we're doing a little bit more transformations with a few different kinds of functions here. And then we'll get into even and odd functions as well to kind of close out the lesson. So anytime the A value, and on this one, just to tell you the similarities. So like, I know you haven't seen absolute value yet, the equation, but it's A times, instead of parentheses, x minus h squared, it's absolute value of x minus h squared, or x minus h plus k. So very similar, if you think about the similarities, y equals a times, I think the other one was x minus h squared plus k. So very similar format. All functions are kind of set up the same way. They all transform the same way. The methods really kind of work the same way. So because the a value here, the number in front of the absolute value, is something other than 1, I typically will write out the 5 points that we have memorized. So in this case, that would be 0, 0, 1, 1. For this function, it's 2, 2 for absolute value, negative 1, 1, and negative 2, 2. So those are the 5 points that, these 5 points basically that you know and love, you have memorized, and they're great. Okay, so when the a value is something other than 1, I multiply the y values by that number, by a. So this is going to be, well, it's still 0. That's going to be 2 now. That's 4. That's 2. And that's 4. So I'm going to plot those points. So it's going to be 0, 0. Well, that stayed in the same spot. 1, 2. 2, 4. Negative 1, 2. And negative 2, 4. So it's still a v, but you can probably see this is a very skinny v. It's gotten skinnier. So when the a value, that's called a vertical stretch. When the a value is bigger than 1, when it's smaller than 1, it's a vertical shrink. And really, that's the only transformation happening to this one. You would say it's a vertical stretch by a factor of 2. And notice that like the points didn't all move up 1. Some stayed in the same spot. This one moved up 1 unit. This one moved up 2 units. The next one would have moved up 3 units to get to there, and so forth. So it's stretching by a factor of 2. All the y values have been doubled. That's essentially what we did there. We doubled all the y values. So the nice thing is once you learn transformations, it works for any function. So again, we're kind of starting with our parent graph, 0, 0, 1, 1, 2, 2. Those are our 5 points we have memorized. And it's a good idea in this case to go ahead and write those out because we have a value that's not 1. So I'm going to write out 0, 0, 1, 1, 2, 2, 3, negative 1, comma, positive 1, and negative 2, comma, positive 2. So those are my 5 points that we know. Because this a value is something other than 1, we know there's a transformation happening. So this is a vertical shrink. That's a small number. So we're going to multiply all the y values by 1/2. So that's still 0. That's now 1/2. Half of 2 is 1. Half of 1 is 1/2. And half of 2 is 1. So I'm going to plot those 5 points. So 0, 0, well, that stayed in the same spot. 1, 1/2 is kind of been moved down a half a unit. 2, 1 has been moved down 1 unit. And you plot those points on the other half. See, right now we've got just kind of these 5 points in blue. So now we've got one more, well, actually 2 more transformations, right? So just like before, so in this case, if you see -3 inside the parentheses, in this case, the absolute value, it's going to go to the right, just like it did before. It's because of that minus sign right there, because it's -3. X minus h, x minus 3, h is actually positive 3. It goes to the right. The k value is -2, which means it's going to move down 2. So the 3 transformations: vertical shrink, right 3 units, down 2 units. So I'm going to take every one of these blue points, go 3 to the right and 2 down. That's my new vertex. 3 to the right, that's kind of hard to do, and 2 down, somewhere around there. 3 to the right and 2 down, that's not too bad. 3 to the right and 2 down, or somewhere in that range, and then 3 to the right, down 2, like that. And so you got a nice graph right there. So that's been moved all around and transformed. Okay, let's try this one. So the nice thing now in words, that's 2 different transformations. So the negative reflects across the x-axis. The 3 is a vertical stretch, right? It's going to stretch. It's going to make it kind of skinny. So again, what I tend to do every time here, especially when you're getting used to this, is just go write out all the points you know and love: 0, 0, 1, 1, 2, 2, negative 1, 1, and negative 2, comma 2. So to multiply all the y values by negative 3, that should take care of both transformations in one step, which is really nice. So it's going to be 0, negative 3, negative 2/3. I'm sorry, negative 6, sorry, it's dividing. So 2 times negative 3 is negative 6. 2 times negative 3 times 1 is negative 3. And 2 times negative 3 is negative 6. Sometimes you get lost track of what you're doing. Okay, so plot those 5 points. It's going to be 0, 0, 1, negative 3. So it did reflect it over the x-axis. Negative 1, negative 3, so right down here. 2, negative 6, so right down here, and negative 2, negative 6. So you've got your beautiful graph right here. It's kind of a skinny parabola or skinny absolute value v. It's been reflected over the x-axis and it has been vertically stretched. Okay, let's go back to parabola. Again, it always helps to just kind of know the formula. If you don't know it yet, it's a times x minus h squared plus k. So in this case, the a value, that's actually two different transformations, right? So the negative reflects over the x-axis. The 2 is a vertical stretch, and the 3 is going to move it vertical stretch. And the 3 is going to move it to the right 3. So you get all three transformations happening. Whenever this is something other than 1, I typically just write out the points for this function for a parabola at 0, 0, 1, 1, 2, 4, and negative 1, 1, and negative 2, 4. So all the y values are being multiplied by negative 2. So that's going to be 0, negative 2, wow, negative 8, negative 2, it's a negative, negative 8. It's a negative also. Okay, so 0, 0, 1, negative 2 is about there, negative 1, negative 2. 2, negative 8 is about there, negative 2, negative 8. So right now, that's my parabola, but it has been moved over, right? So this one, I haven't done my, so this goes 3 units to the right. So take all 5 of those points, go 3 units to the right. This one goes 3 to the right. This one goes 3 to the right. This one goes 3 to the right, and this one goes 1, 2, 3 to the right. Looks kind of like this, roughly. And you got it. Square root function, again, we know hopefully you know your parent graph here. That's going to be very important to know your 3 points. So that's going to be 0, 0, 1, 1, and 4, 2. Because I have an a value other than 1, I'm going to actually write out those points. 0, 0, 1, 1, and 4, 2. This is called a vertical stretch. So it should make this parabola kind of stretch up vertically. So now it's going to be 0, 0, 3, and that's 6. So I'm going to plot those points. 0, 0, 1, 3, and 4, 6, right about there. And like the behavior starts at the 0, 0, kind of goes up and to the right. She's going up a lot taller now. And then we have 2 more transformations that are happening here. So this is going to go to the left 2 units and down 5 units. So every point, this starting point goes to the left 2 and down 5. This one goes left 2 and down 1, 2, 3, 4, 5. This one goes left 2, down 1, 2, 3, 4, 5. And so the graph looks roughly like this. It's kind of nifty looking there. Okay, we're finally to even and odd functions. And I think we've done something similar to this But now we're using function notation, so it has a little different look to it. I think we've done symmetry with the y-axis, symmetry with the x-axis, or symmetry with the origin. And those are related. You'll see what that means. In fact, even, another way of saying even is symmetry with the y-axis. And while we're at it, why not? Odd functions are symmetrical with the origin. So not all functions are even or odd. They could be neither, but sometimes they are. So if you remember the test for y-axis symmetry, the test was to plug in negative x. Well, that's pretty much the test here as well. So I'm going to plug it in. So f of negative x equals, instead of x squared, it's going to be negative x squared minus 4. Well, let's just simplify that. When I mean simplify, I mean, is that first number always positive or always negative? When you have a negative squared, that's always positive. So I'm just going to write it as x squared. And then minus 4 didn't change. Is that the same function we started with? Yes. So this has symmetry with the y-axis. You can kind of see the function over here. It certainly does look like the axis symmetry is at the line x equals 0 there. So this is symmetrical with the axis. It does have that kind of test. So even functions are symmetrical with the y-axis. It's basically the same test. You're plugging in negative x, and if it's the same, it is an even function. You can also test to see if something is an odd function. In this case, it's kind of weird, but this is a way of saying it. But remember the test for origin symmetry, which is what an odd function is. You plug in negative x, and everything's the exact opposite, right? That's what we decided before. So if I plug in a negative x, so this would be negative, so f of negative x. So this is a little different than the test for symmetry with the origin, which again, odd is symmetry with the origin. We used to plug in negative x and negative y. Here I'm only plugging in a negative x, but watch what happens here. So I get negative x to the 5th minus 4 times negative x. So f of negative x equals negative x to the 5th. That's always going to be negative, plus 4x. So the problem is that is not the same, right? Because the 4x positive and the 4x negative don't match. So this is no, it does not have, oh wait, no, it passes the test, right? Everything changed. I thought that's what they changed. Both of them changed. This went from a positive x to the 5th to a negative. This one went from a minus to a plus. Everything changed over there. So everything is now the exact opposite. So yes, this does pass the test. I kind of thought about the graph and I was like, oh, this passes, right? Because you can kind of see, this piece, if you rotate it around 180 degrees, it would fall into this piece and vice versa. So that is definitely an odd function right there. And it kind of makes sense. Like, I don't know if you caught this, but, some students just kind of go, oh, I think I got it. Like, they might look at this and actually just go, oh, yeah, I think that's odd. So x to the 5th, x to the 1st, that looks odd. Some students will look at this and go, oh, that looks even. I think that's an even function. Got to be careful with that kind of thinking. Here's what I mean. So, like, look at this one. If you're going to take a guess, I see a couple odd exponents. I'm thinking, well, maybe this one is odd. The test is kind of the same for each one, at least the start of the test. You plug in a negative x. So everywhere there's an x, I'm going to plug in negative x. Let's see, in this case, if I get the same thing. Negative x, I get negative x to the 7th. That term changed sign. Minus x to the 3rd, because that's always negative. That term changed sign. Plus 5, that's the same. So it did not everything changes. So this has neither. It's neither even nor odd. Neither even nor odd. Okay, try plugging in negative x here. We get 3 times negative x squared plus 7. Negative x squared is always positive, so I'm going to read this as 3x squared plus 7. And so yes, this passes the test. right? And you might have seen the x squared, thought, well, I think this is going to pass the test. I think it's going to be an even function. This is even. This is an even function. This is neither even nor odd, so it's neither one. But this one does pass the test. Now, what's sneaky is this, and this kind of the shortcut will mess up some students when they get to this. So I know there's not a variable, but if there was, the variable would be x to the 0 power, because x to the 0 power is 1, so 7 times 1 is 7. That's what it would be. What's interesting, students will give me different answers. Is that even or odd? Like, is the number 0 even or odd? Like 3 is odd, 2 is even. 1 is odd, 0 is even. So 0 is actually an even number. So that's why this is an even number and that's an even number. So it's going to be an even function. If every term is even, as far as the exponents go, it's going to be even. Okay, so let's try this one. Again, the test is plug in negative x. So we get h of negative x equals 2 times negative x squared plus 4 times negative x. When I do that, I simplify, I got 2x squared. That sign, that did not change. Minus 4x, that did. That means this is neither even nor odd. Plug in negative x. You get 3 times negative x to the 8th minus 2 times negative x to the 6th plus 3 times negative x to the 2nd. So that term is always positive, 3x to the 8th, negative to an even power. That's going to become positive when you put it to the 6th power, so it'd be minus 2x to the 6th. That didn't change either, so neither one has changed. Plus 3x squared. So that one didn't change. And by the way, the exponents are all even, aren't they? It definitely passes the test. It's even. That's the lesson.